Assalamualaikum warahmatullahi taala wabarakatuh. Salam guys. So we meet again in our lecture. Okay, so today still in chapter number 1, metal. Okay, relative mass. So the relative mass we can divide it by 2. There is relative atomic mass, AR. So the definition of the relative atomic mass is average mass of one atom of an element compared to 1/12 mass of one carbon-12 atom with the mass 12 gram. Alright, the keyword for the relative atomic mass is, as underlined over there, mass of one atom. Okay, you all should be write down one atom only. And the other keyword is compared to 1/12 mass of one carbon-12 atom. Alright, and then we go to the relative molecular mass, MR. So the definition is a mass of one molecule. If you compare to the relative atomic mass, for the relative molecular mass, it said molecule. Meanwhile, for the relative atomic mass, one atom. Right? So for the relative molecular mass, a mass of one molecule of a compound compared to 1/12 mass of one atom of carbon-12 with the mass 12 gram. Right? You go to the next slide. Okay. So this is the formula to calculate the relative mass. Okay, so the unit that we use is AMU. AMU stands for atomic mass unit. Okay, formula for the relative atomic mass is AR equal to average mass of one atom of element in AMU unit divided to 1/12 times mass of one atom of carbon-12 also in AMU unit. And then we go to the formula for relative molecular mass, MR. MR equal to average mass of one molecule of substance in AMU unit also divided by 1/12 times mass of one atom of carbon-12 also in AMU unit. Alright. So you all should know or should memorize these two formula to calculate the relative mass, atomic or molecular. Right? And then we go to the next slide. Okay, still here. Okay, both AR and MR are dimensionless, have no unit. Okay, so next slide. So this is the device that we use to measure the mass spectrum. Okay, so the device is mass spectrometer. Okay, this is the device. Right, you can look at the picture over there. Right, and then okay, how the mass spectrometer doing to measure the mass spectrum. How is it? So the firstly gas sample enter here. All right, where is it? Wait up. Oh, sorry. Okay. All right. So gas sample enter here, and then moving inside the tube over there, go through filament current, ionize the gas. Okay, enter here, and then at this part, ion accelerate toward charge slick. So the element with the sample will be accelerate over there. Alright, And then, as this birthmark, magnetic field is deflect and the lightest ion. Alright, so yeah, they always deflects, right? Alright. So ion separate by mass expose field, and then at the end we will manage to get the mass spectrum. Based to their mass, we can divide it, the element or something that we want to do, something element from the periodic table, up to you. All right, okay, so we go to the next slide. Oh, sorry, yeah, first, right. Okay, here is the example for magnesium. So you all can see the y-axis is the relative abundance, or the Q. So can be percentage, ratio, or fraction, right? And then the x-axis is the mass in EMU unit. Alright, so this is the magnesium. So magnesium 24, the abundance is 63. Magnesium 25, the abundance okay, again alright, never mind. Technical problem here. Alright, so magnesium 25, the abundance 8.1. The magnesium 26, the abundance 9.1. Alright, so the mass spectrum of magnesium show that magnesium consists of 3 isotopes. Before this, you all already know what is it, the definition of isotope, right? So magnesium 24, magnesium 25, and magnesium 26. There is 3 isotopes here. All is magnesium. Alright, the height of each line is proportional to the abundance of each isotope. Talk about this one. 63, 8.1, 9.1. And then if we look at the graph over there, magnesium 24 is the most abundant of these 3 isotopes. Okay, we move to the next slide. Alright, how to calculate the average atomic mass from mass spectrum? Okay, so the formula that you all should know or should memorize. I hope that you all memorize this formula. So the average atomic mass, you all must write down like this. Average atomic mass equal to the sum of Qi times Mi divided by the sum of Qi, or the total. The total of Qi times Mi divided by the total of Qi, and the unit is AMU, atomic mass spectrum. Okay, and then okay, what is Q? You already know. Before this, I already explained to you all about the Q, right? The relative, or the fractional, or the ratio, or the percentage abundance of isotope of the element in the mixture. Meanwhile, for the M, the isotopic mass of the element in unit AMU. Alright. Okay. So when you talk about average atomic mass, of course, there is a unit. The unit of average atomic mass is AMU. Okay. Atomic mass unit. Alright. And then Go to the next slide. Okay. So this one we will continue to the next period. All right. Okay, guys. I hope you all understand about the lecture today. And if you don't understand, you can join my Telegram in my description, and then I will brief again over there. All right, guys. Thank you.